Galileo Galilei, the man who redefined the cosmos. Through telescopic discoveries and confrontations with the Church, Galileo Galilei was born in Pisa, Italy in 1564. As the eldest son of a musician and scholar, he was exposed to the humanities and sciences from an early age. He later enrolled at the University of Pisa, initially to study medicine, but his curiosity soon drew him towards mathematics and physics. The 17th century was a period of profound intellectual ferment, particularly in astronomy and physics. This era, marked by the Renaissance's embrace of inquiry and the Reformation's challenge to authority, set the stage for Galileo's groundbreaking work. His theories emerged in a time ripe for questioning traditional views of the cosmos. Before Galileo, the prevailing cosmological model was geocentric, placing Earth at the universe's center. This theory, rooted in the ideas of Aristotle and Ptolemy, was widely accepted due to its alignment with the philosophical and religious doctrines of the time, making any challenge to this view both revolutionary and contentious. Galileo's interest in the heavens was ignited by reports of a mysterious, starry messenger, the telescope. This new tool had just been invented in the Netherlands. Captivated, Galileo quickly engaged with this technology, which allowed him closer observations of the celestial bodies than ever before possible. His enhancements to the telescope were significant, transforming it from a curious novelty into a powerful instrument of science. Galileo increased its magnification, which enabled him to observe celestial phenomena in unprecedented detail. This improvement opened the door to discoveries that would challenge the very structure of the cosmos. Galileo made significant enhancements to the telescope, a device originally invented in the Netherlands. By refining the lens crafting process, he increased the magnification from 3x to about 30x. This allowed him to observe celestial bodies with unparalleled clarity, revolutionizing the way astronomers studied the heavens. With his improved telescope, Galileo discovered 4 moons orbiting Jupiter in 1610. This monumental finding challenged the prevailing geocentric model of the universe, which posited that all celestial bodies revolved around the Earth. The existence of these moons supported the heliocentric theory, suggesting that not everything in the cosmos orbited our planet. Galileo's observations extended to Venus, where he noted the planet exhibited phases similar to the Moon. These observations were incompatible with the geocentric model, which could not account for such phenomena. This provided further robust evidence in favor of the heliocentric model proposed by Copernicus. Turning his telescope to the Milky Way, Galileo discovered that it was not a single cloud-like entity as previously thought, but a collection of countless stars. This finding expanded the known boundaries of the universe and added to the growing body of evidence that contradicted traditional astronomical beliefs. The debate of Galileo, who engaged in discussions and disputes with other scientists like Jesuit astronomer Orazio Grassi. Galileo's assertions about the nature of comets, suggesting they were optical illusions rather than physical entities, sparked controversy and further fueled the scientific discourse of the era. Galileo Galilei's contribution to the understanding of motion and physics revolutionized the way we perceive the natural world. His observations and experiments laid the foundational principles of inertia and accelerated motion, challenging the Aristotelian belief that heavier objects fall faster than lighter ones. With the publication of Sidereus Nuncius, or Starry Messenger, Galileo astounded Europe by revealing the heavens in unprecedented detail. His descriptions of the Moon's craggy surface and the discovery of Jupiter's moons provided solid support for the Copernican system and expanded our view of the universe. Galileo staunchly defended the heliocentric model proposed by Copernicus, which placed the Sun at the center of the universe, contrary to the prevailing geocentric model endorsed by the Church. His defense was rooted not in rebellion, but in his observations and logical reasoning, which supported a sun-centered universe. The Church initially reacted with caution to Galileo's findings. Though his discoveries were marveled at, They also caused unease among the theologians who saw them as contradicting the literal interpretations of the scriptures. This tension marked the beginning of a fraught relationship between Galileo and the ecclesiastical authorities. Galileo's interactions with the Pope and the Roman Church were complex, influenced by his fame and the volatile scientific and religious climate of the time. While initially receiving encouragement from some church officials, his continued advocacy for heliocentrism eventually led to conflict, casting a shadow over his relationship with the church. Galileo faced intense scrutiny under the Inquisition in 1616 due to his support for heliocentrism, which contradicted the Church's geocentric doctrine. This pivotal encounter marked the beginning of serious opposition from the Church towards Galileo, as they warned him to abandon his advocacy for Copernican theory. Despite the warning, Galileo continued his research and published Dialogue Concerning the Two Chief World Systems in 1632. This work openly supported heliocentrism and invited controversy by seemingly mocking the Pope, who had previously been sympathetic to Galileo. This publication dramatically escalated tensions with the Church. The situation culminated in the infamous trial of Galileo by the Inquisition in 1633. Accused of heresy for his heliocentric views, the trial was a critical moment in the conflict between science and religious doctrine. Galileo was found vehemently suspect of heresy and was forced to recant. The recantation had profound implications for the scientific community, signaling the Church's power over scientific discourse. Galileo's abjuration dampened the spirit of inquiry and set back the acceptance of heliocentric models and other scientific advancements. Living under house arrest after his trial, Galileo continued his work in a more subdued manner. This period led to lesser-known yet significant contributions, refining earlier theories and mentoring future scholars, thus maintaining his influence on science against all odds. Galileo Galilei's life took a dramatic turn after his conviction for heresy, leading to his house arrest. Despite these restrictions, he continued his work, focusing on mechanics and the motion of bodies. His later studies laid foundational principles for what would eventually become classical mechanics, demonstrating his unyielding commitment to science, even in isolation. Under house arrest, Galileo developed his scientific methodologies further, emphasizing systematic observation and mathematical validation. This approach not only solidified the basis of empirical science, but also encouraged future scientists to adopt and refine these methods. His unwavering dedication to the scientific method during these trying times marked a significant contribution to scientific philosophy. Galileo's work on motion, had a profound impact on the field of physics. His insights that objects accelerate at a constant rate regardless of their mass challenged existing notions and paved the way for Newtonian physics. This shift was critical for the advancement of modern science. In laying the groundwork, Galileo's role was pivotal. By integrating mathematics with experimental evidence, he transformed the very nature of physics from a theoretical philosophy into an applied science. His methodologies and discoveries continued to influence the scientific community, shaping the future of technology and theoretical inquiry. Reflecting on Galileo's astronomical discoveries, it's clear how his observations and theories revolutionized humanity's understanding of the universe. By proving that Earth was not the center of everything, his work not only challenged the prevailing geocentric model, but also fundamentally altered the course of astronomy, setting the stage for all future celestial research. Galileo Galilei's contributions ignited the scientific revolution, fundamentally transforming how we perceive our universe. His advocacy for the heliocentric model challenged existing doctrines and laid foundational principles for modern science. His legacy is evident in every telescope that scans the heavens and every physics class that discusses motion and force. The Church's standing condemnation of Galileo was eventually reconsidered, marking a significant shift in its relationship with science. Centuries later, in 1992, Pope John Paul II formally acknowledged the Church's error in handling Galileo's case. This rehabilitation highlighted the evolution of the Church's stance on scientific inquiry and its integration with religious beliefs. Galileo's conflict with the Church remains a poignant lesson in the history of science communication. Modern assessments emphasize the complexities of his trial, reflecting on the intersection of science, politics, and religion. This reassessment helps contemporary society understand the importance of maintaining dialogue between scientific and religious communities. The scientific method remains a cornerstone of scientific inquiry. His insistence on empirical evidence and systematic experimentation set standards that define scientific practice today. Galileo's approach has enabled generations of scientists to build on solid foundations of observable, repeatable, and falsifiable research. Educational systems owe a great deal to Galileo's methods and discoveries. His hands-on, inquiry-based approach to learning continues to influence educational reforms. By promoting critical thinking and empirical evidence, educators empower students to question conventional wisdom and explore the universe with open minds and rigorous methods. Galileo Galilei, though primarily for his contributions to astronomy and physics, was also a profound mathematician. His mathematical work laid the foundation for the development of kinematics and dynamics. He explored the concept of acceleration and the parabolic trajectory of projectiles, intertwining mathematics rigorously with physical observations. The cultural impact of Galileo extends literature and art, reflecting his monumental shift in how humanity perceives the universe. His figure has been depicted in numerous works, symbolizing the struggle for intellectual freedom and the pursuit of knowledge. His story inspires artistic expressions that resonate with themes of enlightenment and conflict. Patronage played a crucial role in Galileo's scientific pursuits, as was common in the Renaissance period. Influential patrons like the Medici family supported his work financially and politically, allowing him the resources to focus on his research. This backing was vital for his discoveries and also for his survival during times of controversy. Comparing Galileo's trials with other historical conflicts, such as the rejection of Semmelweis's antiseptic procedures, highlights a recurring theme of initial resistance faced by new ideas. These conflicts illustrate the challenging path of scientific acceptance and the eventual triumph of evidence-based reasoning over established beliefs. Galileo's personal life is less known compared to his scientific exploits. He had 3 children with Marina Gamba. Their daughters were sent to a convent, and his son was legitimized and studied medicine. His personal correspondence and less famous writings reveal a man deeply connected to his family and contemporaries. The preservation and study of Galileo's manuscripts and instruments have been crucial in understanding his contributions to science. Museums and research institutions around the world hold these precious items, offering insight into his innovative methods and the challenges he faced during his lifetime. The role of technology in spreading Galileo's ideas cannot be overstated. The printing press played a pivotal role in the dissemination of his works, allowing his revolutionary views to reach a broader audience. This, in turn, catalyzed further scientific inquiry and discussions across Galileo's work not only influenced his contemporaries, but also paved the way for future scientific giants like Sir Isaac Newton. His observations and theories laid the foundational stones for classical mechanics, which Newton would later build upon to formulate the law of universal gravitation. Reflecting on what modern science owes to Galileo Galilei reveals a debt of foundational concepts in physics and astronomy. His courage to challenge prevailing notions and his development of empirical evidence collection methods are pillars on which modern scientific inquiry stands. Galileo's place in history is established as one of the key figures of the scientific revolution. His legacy of questioning established beliefs and his methodological contributions continue to influence scientific thought and education, underscoring the ongoing relevance of his work in today's scientific endeavours.